let's talk about page 2 of this worksheet that we did in class on Friday. And for 3a, if we're looking for a polynomial at x is equal to 0, in fact, we also could call this a Maclaurin. So we need to take our derivatives. So let's see, we need f of 0, in fact, which is going to give us -5. We need our first derivative, which we know is going to give us 6x squared minus 6x plus 4. Our second derivative, which in fact is going to give us 12x minus 6. And our third derivative, which is going to give us 12. So f prime of 0 is 4. F double prime of 0 is -6. F triple prime of 0 is 12. So our polynomial then, let's see, and this is a third order, so we're going to have -5 plus 4x plus -6 over 2 factorial, x squared plus 12 over 3 factorial x to the 4th. And if we simplify that, this is going to give us -5 plus 4x minus 3, x squared, 3 factorial is 6, so we're going to get plus 2, x to the 3rd, which is not a surprise because here we are approximating a polynomial with a polynomial. So there's only one equation that we can have, a polynomial equation through that set of points. Let's do the same thing at x is equal to 1, and I'm a little bit wiser now. So I'm just going to still take my derivatives, and my polynomial here is going to be, well, let's see, I need to plug in 1 to all of these. So I'm just going to make a little note. F of 1, in fact, if I plug in 1, that's -1 plus -1, that's -2. My second derivative at 1 is 6 minus 6 plus 4, so that's 4. The second derivative at 1 is going to give me 6. The third derivative at 1 is going to give me 12. So my polynomial, now this is not a Maclaurin, so this is going to be -2 plus 4 x minus 1 plus 6 over 2 factorial x minus 1 squared plus 12 over 3 factorial x minus 1 cubed. And I'm just going to work this out. This would be okay, but I'm going to work this out a little bit. -2 plus 4 x minus 1 plus, again, this is going to give us 3. And I'm going to work this out. This is x squared minus 2x plus 1, and this is 12 divided by 3. So once again, that's 3 factorial, so that's going to give us 2. And the expansion for x minus 1 cubed, I know, is x cubed. I do know how to do this, so my next term I know is going to be 3x squared. 6 divided by 2 is, so I'm going to have minus, I'm sorry, this is minus here, minus 3x squared plus 3x minus 1. You might remember that little trick. So wait, let's just put this all together. -2 plus 4x minus 4, 3x squared minus 6x plus 3, 2, x to the 3rd minus 6x squared plus 6x minus 2. And when we combine like terms, we have 2 x to the 3rd. We have minus 3 x squared. Let me just keep track of that. We're going to have -2x plus 6x, 4x, -2, -6, -8, minus 5. Oh, goodness gracious. Look, we get exactly what we had before. Okay, let's just practice a little more. Again, Taylor polynomial, not Maclaurin. F of x is x to the -1. I'm going to take my derivatives. The first derivative is -1, x to the -2. The second derivative is +2, x to the -3rd. The third derivative is -6, x to the -4th. And now I'm looking for this at a is equal to 2. So f of 2 is 1/2. F prime of 2 is -1/4. F double prime of 2 becomes 2/8, which is +1/4. And f triple prime of 2 becomes -6 over 16, which is -3 over 8. Okay, so now let's work this out. Our polynomial of degree 0 is just going to be 1/2. degree 1 is going to be linear, 1/2 plus negative 1/4 x minus 2. P sub 2 is going to be 1/2 minus 1/4 x minus 2. And then I'm going to have plus 1/4. I'm dividing that by 2 factorial. So I'm going to think of it as times 1 over 2 factorial. So P sub 2 simplifies into 1/2 minus 1/4 x minus 2 plus 1/8 x minus 2 squared. And P sub 3 is 1/2 minus 1/4 x minus 2, the whole thing. And then I'm going to have minus 3/8 times 1 over 3 factorial. The 3's are going to cancel, so I'm going to have minus 1/16 x minus 2 to the 3rd. Okay, and there we have it. Now for sine x, I'm going to skip this because we're looking for the Maclaurin polynomial right around 0. And you had this for homework the other night. So what you might have noticed is that sine x is an odd function. And we get this alternating series. Okay, so if I want a polynomial of degree 0, that's just going to be 0. A polynomial of degree 1 is x, so what we're saying is that sine x, or linear function, goes right through the origin. Polynomial of degree 2 is going to be the same as polynomial of degree 1, because our x squared term is out of there. Polynomial of degree 3 is x minus x to the 3rd over 3 factorial. And I'm going to think about the same thing with cosine of x. But what I'm going to do is cheat a little bit, or two things. One thing I know from last night is that the expansion is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, blah, 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 blah. The other thing I know is that cosine is the derivative of sine. So the expansion for cosine should be the same as the derivative of the expansion for sine. Which is 1 minus 3 x to the 3rd, x squared over 3 factorial plus 5 over 5 factorial x to the 4th minus 7 factorial x to the 6th. And this just ends up being 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, which is in fact the expansion for cosine. And I'm going to stop this right now and come back and do C later.